In this video, we're going to go over one of the ideas from section 2.3, and that is the idea of significance level. FYI, there's some other concepts in section 2.3 about types of errors, and we are not covering those. So let's just do a little sort of review first. So we use the p-value when we want to evaluate the strength of evidence against the null hypothesis when we create a hypothesis test. And now we're going to look at making a decision about whether we should actually reject the null hypothesis. And so what we use to be able to make that decision is this thing called a significance level. Now, example 2.3 is about heart transplant operations. So there was a hospital in London called St. George's, and in September of 2000, they suspended all of their heart transplant operations. In the last 10 heart transplants they had had, 80% of them had resulted in death within 30 days of the transplant. And it was reported that this was over 5 times the national average. So I'd like you to pause the video for a moment and write down for yourself what are the observational units, what is the sample size, what is the variable, and what type of variable is it. So the observational units in this case are the heart transplants. The sample size is 10. There were 10 of them. Okay, so the observational units are the heart transplant operations. There were 10 of those. The variable is whether there was a death within 30 days of the transplant. And of course, that is a categorical variable, and it's also actually binary as well. Alright, so we're going to create these two hypotheses. In this case, the null hypothesis is that the probability of dying within 30 days of a heart transplant, so notice, dying is considered the success outcome in this case. That probability is the same as it is nationally, in other words, pi equals 0.15. So I just want to note a couple things. First of all, our variable is categorical, and so our parameter symbol is pi. This pi is, you could think of as a long-run proportion of deaths from heart transplant operations. Notice we're not really assuming random chance in this null hypothesis. We're not saying there's a 50-50 chance of dying. We're saying that nationally, about 15% of all heart transplant patients die within 30 days of the operation. And so we're going to start by assuming that at St. George's the rate is also 0.15. So we're not really talking about things due to random chance. We're talking about the probability at this hospital being the same as it is nationwide. And then the alternative hypothesis, the conjecture, is that actually the probability of dying is higher at St. George's than it is for the rest of the country, so that pi is greater than 0.15. All right, so let's review our 3S strategy. The first S stands for statistic, and what is the statistic in this case? And you should again pause the video and write down for yourself not only the number, but also the symbol. So in this case, with a categorical variable, the symbol for the statistic is p hat, and that is 8 out of 10, or 0.8, so that is the proportion of successes observed in the sample data. So out of the last 10 transplant operations, they had 8 deaths, and again, death is considered success in this case, and so our p hat statistic value is 0.8. The next S in the 3S strategy is simulate. So we'd use the one proportion applet to simulate 1,000 repetitions of 10 heart transplants using 0.15 for the death probability, so the assumption that's in our null hypothesis. And then the third S is for strength of evidence, so we're going to find the p-value and use that to evaluate the strength of evidence against the null hypothesis. So I have here a screenshot from the one proportion applet. And again, best thing for you to do is pause the video, open the applet yourself, and fill it in with the appropriate numbers. And I'm going to go through and fill them in a moment. But much, much better for your learning is to actually try to do it yourself. So again, we're going to put in the top box what we're assuming in the null hypothesis, that the probability of success is 0.15. Our sample size n is 10. And we are going to go ahead and do 1,000 samples. And it creates the distribution that you see there on the right-hand side, and you should have one similar to that if you did this on the computer. So note to self, our assumed probability of success matches up with the mean of this distribution, and I did click on summary stats to get that. The standard deviation, what you could do is take the square root of 0.15 times 1 minus 0.15, all divided by sample size of 10. And again, I strongly encourage you to pause the video, try to calculate that with your own technology, and what you should get is 0.113 approximately. So that's pretty close to what we have here from the applet. Okay, and then again, what we want to do is find a p-value. Now you should be able to look at this graph on the right-hand side, this null distribution, and you ought to be able to tell what kind of p-value you're going to get. Now remember, into the count box goes the statistic, and the symbol we're going to keep as the default here, that, well, I'm going to put matches in quotes. It's not the same symbol because this one has an or equal to, but it goes in the same direction as the symbol in the alternative hypothesis. Now if you're doing this on the computer, what you're going to see is a red line, and your graph is going to look a little bit different because mine does not have room for 0.8. It wasn't even in the picture originally, but you'll have a red line at 0.8. It's looking for any sample statistic simulated p-hats that came out at least as big as the 0.8, and I can already tell you that there are 0 out of 1,000, so that will be in your applet. I can't remember exactly what it looks like in the applet because I don't have that up right now, but it'll be listed there. I think it says proportion, I don't remember what it says, but the p-value is 0 out of 1,000, and it will show up in red. Okay, so for us the p-value is 0 out of 1,000, and I usually don't just write 0. I usually, when the numerator is 0, I usually do keep the over 1,000 there, just so that the reader knows that I didn't do infinitely many, or 10,000 or 50,000. I did 1,000 repetitions. With a p-value of 0 out of 1,000, again, if you don't have your formula sheet nearby, why don't you pause the video and get that and take a look and see if you can find the strength of evidence in the guidelines there. In this case, the strength of evidence against the null hypothesis would be very strong. That's the last row in the table. And I wrote out the conclusion in context, so our statistic, that is p-hat equal 0.8, provides very strong evidence that the death rate is higher than the national rate. And then the question is it appropriate to use a theory-based test in this case, and why or why not? So let's go back to the previous page here, and notice that this null distribution is not actually bell-shaped, it's right skewed. Okay, and there were 8 successes and only 2 failures in the sample, in the data. And in order to use a theory-based approach, we should have at least 10 successes and 10 failures. Well, I'll just say it like this. theory-based approach is not appropriate. We didn't have at least 10 of each. So note to self, when somebody asks you, is it appropriate to use a theory-based approach, rather than just saying yes because there are at least 10 successes and 10 failures in the sample, or no because there weren't at least 10 of each, you should actually say how many of each were there. There were 8 successes and 2 failures in this sample, so it wouldn't be appropriate to use a theory-based approach. And in the theory-based approach, our null distribution curve, that perfectly formed theoretical curve, would actually be bell-shaped. It wouldn't come out right skewed, and that's because we don't have the right number of successes and failures. So the light blue curve we would get from the theory-based approach does not match up well to the actual null distribution in this case.